All right, FRQ 7, let's get right into it. Differential equations, and I'm asked to sketch a slope field, but just sketch the curve. I already have the slope field. Now note this is dy dx y plus 5 sine x. It's kind of weird. You got y and x. So if you tried to solve that for y, you couldn't do it very easily because you'd have, oh no, you could, but it'd be interesting because you'd have a sine x and a divided by sine x thing. It would be interesting. But anyway, my slope should be something with trig, and this graph looks like that. And I'm supposed to go through 0, -4. So I just start here. Okay, so here's my dot. And right there, it levels off, and then it starts to slope up and slope up on both sides. And now, it could, I mean, it almost looks like it goes, way up here. Except I know that it is trig, and the slopes start to decrease. So somewhere around here, I'm going to want to turn, and I'm going to want to level off again, probably around here. And then it looks like it's trig. It looks like it levels back off. So I'll just kind of, sketch that over here. I don't know, roughly something like that. So something like that. Okay. And you could see the answer key, I think didn't go up quite as high as mine, but something like that. Now write an equation for the line tangent to the solution. Oh, okay. So write an equation of a line tangent, so I just need a point and a slope. I already have a point, so I could already start that. So my tangent line is going to be y equals -4, and then I would do plus the slope and x minus 0. So I need to find the slope. So dy dx at 0, -4 is dy dx is what was given, so it'd be -4 plus 5 times sine of 0. But sine of 0 is 0, and so that whole thing is 0, and so this is my tangent line. It's just plugging in the point and the slope. Okay. Now, is it an over or underestimate? It's clearly going to be an underestimate, because just look at the graph. If I were to now say I'm going to approximate this by that line, it's sloping up. Now okay. Now what I just did there is kind of confusing. This graph, the red graph, is a potential. This is the idea here. The red graph is a potential graph of f, where f's derivative is y plus 5 sine x. So my f is probably some version of cosine, which is what my graph looked like. I didn't say that right the first time. But so here, yes, that blue line does seem to be an underestimate because the graph is curving up and away, because the slopes are positive. But so how do I actually justify that? Now, I'm not very confident in what actually needs to be shown here as a legit justification. I think the way to go would simply be, if it's concave up there, that proves it's a overestimate. And so that's what I would say. And then to show that, you really should find that. And so I have to find that, I do this whole thing. That equals, and then I just have to find the second derivative, which is find the derivative of the derivative, which is a product rule with implicit, and then plug in 0, -4. Actually, then just state, hey, look at that, the second derivative is in fact positive. So if the second derivative, if f is concave up, then my tangent line is always an underestimate. And so I just need to say second derivative is positive there. So I'll just show you. So that's what they did down here. I don't need to reinvent it. So they took the second derivative, which you had to do product rule for that. That's what, where's my thing? That's what this is. This is just product rule. And then this dy dx was just putting back in, well, this actually is dy dx right here. So timesing this by dy dx just squared both. That's all they did there. And the whole point of all of this was just to say that it's positive at this point, and it's positive for everywhere in this interval. It's positive all the way until where? All the way until, well, I'm not sure, actually. I guess these are both always positive, so it'd just be where is this more negative than that? I don't know. But it's positive for this whole interval. Now, all of this justification looks like it's only worth 1 point. So I don't know. I'm not too worried about that one. All your points on one of these would come from solving the separable differential equation, which is what part C asks to do. Find the particular solution with that initial condition. And so that's where, I'll just go through their work and highlight it. So that's where you just start with that and you separate them. You don't add or subtract. You just divide it over. And then you integrate both sides. So the left, like usual, becomes ln, and then the right becomes cosine. Now you have to have the plus c on one of the sides. You don't have to have it on both, but if you don't have this, you stop here at usually 2 points, one for each integral, or sorry, one for separating, one for this integral, maybe two, one for each integral, but then that would be it if you don't put this plus c. And then you evaluate the c, so you plug in -4 and 0, and you find that c is 1. You don't have to have other steps there, you just can state it, c is 1. Then you go back to here with the 1 in, and then you solve for y, so you e2 and move it over. Now you could have done this differently and put in the c. You could have solved for c down here, where you'd still have a c up here, and you get in that weird form. That's legal, but this is kind of more standard. You could end up with a slightly different answer if you did like the ShamWow C. But this is a perfectly acceptable answer. And then, they got rid of the absolute value and chose the positive version because f of 0 is -4. So you'd think you'd pick the negative version, but no, because if you put a negative in there, then it would be -6. Or no, negative, I don't know what it would be. It wouldn't give you -5 like it's supposed to, or -4 like it's supposed to. Note the solution is valid. Okay, and so then they said 4 points. Now that's going to be worth more actually. That's going to be 1 for separation. Where's that? 1 for separation, 1 for antiderivatives. I would think that would have 2. 1 there, 3, 4. Well, I don't know, maybe. Usually that's a 5-point thing. And there you go. Okay.